Alright, I want to talk to you guys about this. This guy, Doujin Dance, on YouTube, is a console modder who lives in China. And he sells modified console gaming systems, old school ones, that have little upgrades like, um, I don't know, improving the sound quality or the visual quality of the game. Just little tweaks and hacks and stuff. Um, and he's sold thousands of modded consoles on eBay over the years. His older videos would be in like a really cool prototyping style with boards that were done in a prototyper kind of way. Um, but then his more recent videos, he's starting to do like actual printed circuit boards because he got criticized for his prototyping work, which I think was unfair. He's a very fast worker, so it kind of looks like he's sloppy, but he's actually doing great work, and he wouldn't be getting that many sales and positive feedback if he wasn't doing good work. It's just other elitist console modders that when they mod consoles that he's already modded, because okay, so like let's say I buy a console mod or I buy a console that has been hacked or modded by Doujin Dance on eBay. I buy it, I use it for 10 years, and then something goes wrong, some electronic part failure or whatever. I'm not going to ship it to China back to Doujin Dance to make the repair because shipping it to China would cost $100 or something. I'm going to ship it to a US console modder. And then I ship it to the US console modder, and he has a YouTube video, and he does a video on the repair job. And when he opens up Doujin Dance's console mod, he criticizes it and says it looks like crap, blah, 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 it's not professional. But I disagree with that. I think he does a really nice job. And I'm studying, this is a mod he made, a one-chip digital analog converter. And this blue board is not a custom PCB actually. This is a stock PCB which you can find on eBay. It looks like this is about 16 pins per side, and there's 4 sides, so 1632, 1632, a 64 pin chip. It's a SOP form factor, SOP 64 pin chip, and then it has all the little traces for it. And then it has printed circuit board little lines leading to a bunch of drilled holes, which are plated through holes that enable you to connect wire to the chip by connecting the wire to the plated through holes. Now, this board is used because it would be very difficult to solder each of these wires directly onto this chip. Plus, if you wanted to add any little capacitors or whatever to the chip, you could possibly do it on this board as like a backdrop. But it just makes it easier in general. You can see here some little wires curving up and down. That's shorting out certain pins. So I guess he wanted to short them for whatever reason. Unless if that's just the leg of a component, maybe that could be a diode or something. Now, one thing I found really interesting is these wires coming off of it. He doesn't insert them into the plated through hole. Instead, he lays the wire across the top face of the plated through hole and solders it onto the face of it. Now, this actually is really interesting because it prevents you from creating a 90-degree kink in the wire, which would otherwise happen if you were to stick the wire in and then bend it 90 degrees and then solder it, which would be possibly or not possibly, but surely substantially more likely to fail because of the bent 90-degree angle, and then to top it off, the solder creates um, some damage to the structure of the wire because of the extreme heat, and it makes the wire kind of brittle where the solder is applied. And so if you have that kinked angle plus the solder, that's a recipe for disaster. So this is a great tip that when wanting to come off of a proto board or any board, any type of circuit board, take wires off of it to go to some other part. The fastest and best way to do that is just to trim off the insulation off the very tip of the wire, lay it across the plated through hole, and put a little bead of solder on it, and that's it. You're done. Now, an even better way would be to use male header pins. Plug that in, and then bend that at a 90-degree angle, and then use DuPont connectors, which are the same kind of connectors on jumper wires you buy from a beginner's electronics kit. Use female DuPont connectors and plug that into the header pins, and then send your wires out that way so that there's no soldering involved except soldering on the header pins. And the wires themselves won't be prone to failure because they're using crimp connections with the DuPont connector. They're not soldered at all. They're not pre-tin, they're not anything. And so that would be even better. But then nothing. I think that would be fine, except it would be probably good to also electrical tape the header to the DuPont connectors so they don't accidentally unplug. But I think the accidental unplugging is probably pretty unlikely inside a console. But in the case of a robotics project, you always want to electrical tape your connectors to make sure they don't accidentally pull apart from vibrations over time. So I just think that's really interesting that he also has the wires soldered so that in the direction they're running. So like this yellow wire right here going to this upper left pin up here, 12 o'clock, you can see it's just laid across this little plated through hole at a 45-degree angle and already flowing in the direction he wants it. So he doesn't just solder them in vertical and then bend them after the fact. That would be very bad for the soldered joint. He lays them across the joint and solders it. So he's actually demonstrating some really incredible technique here. By the way, the wire he uses appears to be Kynar 30 gauge wire. But another modder said that he thinks this guy is using Ethernet cable wire. So either one of those would be fine, I guess. Now, just to prove what I mean about you can buy those boards off eBay, it's not a custom board. And you just buy them in bulk and just store them because they're dirt cheap. Wake up. SOP 64. Press space. DIP adapter. Press return. Alright guys, so here I found one. It's not the same color as what he has, but you'll get the idea. So, stop listening. So here's something like what he had. You can see that the chip would go right here, like that. And it will also take chips of any size, like this smaller size and then up to the bigger size. He's using the bigger size, the full 64 pins. And you can see that the little traces work their way out to each of the plated through holes. And the plated through holes all come along the outsides. So the advantage to a board like this is you don't have to try to solder wires onto each of these very tiny gapped pins here. Instead, you solder the wires onto the plated through holes. And so like what I was saying, rather than insert the wires vertically and solder them into the through hole and then bend it at a 90-degree angle, putting a lot of stress on the joint, he just lays the wire across the plated through hole in the direction he wants it to go, and then just solders it right then and there across it, never having the wire insert at all. I thought that was really excellent technique, really clever. And yeah, he just has all the wires flow off of this thing in one direction. It was really nice to look at. So that's how you buy them, and he just buys a bunch of these, and they're dirt cheap. $4.41 for 30 of them, and that comes out to, well, if it was 10 of them, that'd be 44 cents. Divide that by 3. Like 12 cents per board. 12 cents per board. So that's way cheaper than trying to buy a printed circuit board or make your own printed circuit boards. You just pay 12 cents a board for this generic board that's usable for like any project, and it's ready to go. And you just put your SOP 64, TQFP 64, whatever. You put your chip on there, and boom. So yeah, it's great, man. It's absolutely great. That's the way to do it. And that's how he's doing it. So this is just a different color board. It's blue, but it's the same exact thing. You can see the chip applied to it, and you can see how he's flowing the wires off. And it's very impressive. That's a way you can, I don't know, create interfaces onto chips with the chip on its own board with wires coming in and wires coming out. Now, he wraps the whole thing after he's done in bubble wrap, and I'd be curious if anyone could let me know what's wrong with that. Somebody said it's bad because it can build up electrostatic and lead to a potential electrostatic discharge, which could damage components. Clearly he's using it just to pad it so that when he puts it back into the console, he puts a little piece of tape over the bubble wrap, and it's just kind of wrapping the board up, preventing during shipping it from bouncing around inside there and stuff, and it avoids you having to drill and tap the board and screw in this modded thing to the original board in order to preserve the original board. I guess nowadays he got fancy and he 3D prints a kind of clasping mechanism that slides onto the board, and then he slides that onto these boards, and there's no damage of the original board, which are kind of like relics or artifacts. You don't want to cut into them if you can avoid it. So he doesn't need to put the bubble wrap, so that keeps it all stationary and keeps it from moving around. Which is really clever. But I don't know that this bubble wrap idea is bad for sure. I'd be interested to hear other people's opinions on that. I mean, it is plastic. It's not rubber. I don't know if plastic builds up electrostatic or just rubber like balloons. I'm not sure how that works, but yeah, anyways. I just feel that this guy is a master and he's so fast at prototyping work. This is another one of those boards. This is a 44 pin QFP 44. So he just has to buy the chip he wants that will do something, and then he's got all these um, plated through holes to put his wires into, which are nice and big and spread out, because it'd be too hard to get them onto this board. I mean, he can do that, get them onto the board, but this kind of makes it all a lot more stable and makes it easier to access for a human. Oh, and as you can see right here, he has a capacitor, I believe. A tantalum capacitor. I believe that's what it is. So you can actually put components on this plated through-hole board as well. So that's another advantage of using that technique. He's using some solid core 24 gauge wire to jump various pins of this chip as well, it appears. Which is good to observe, good to know as a tool. It's a good technique. Okay, so he puts components on the back too. I'm against that, just because I like to see everything from the top. I don't like to have to flip to see what's going on the bottom, and then try to figure out how it all works together in my mind using inverse, upside down mental image of what the bottom looks like and how that would translate to the top. In seeing that all in my mind, it's just like, you know what, just put all the circuitry on the top of boards, for crying out loud. I hate the whole concept of double-sided boards. I think that every bit of information you need should be visible on the top. Oh, you know what? I think that's called Manhattan style solder work, when you have all this bare metal soldered to each other. That's so cool to look at. I'm gonna have to do that more. Just bare metal to bare metal like that. That's cool. It's like a rail, a communication bus or something. With the solid wire just forking right off it. Beautiful. I gotta do that. This guy's a master, man. He doesn't want to order out printed circuit boards. It's cheaper just to buy these generic boards and buy the chips and just do it yourself. Eventually, due to outside pressure, he does cave in and start ordering printed circuit boards because other modders think it doesn't look good enough when you use generic circuit boards. But I think that's ridiculous.